Okay, so the question says, find the value of x if we know that the gradient to this function is exactly 5. So now what the exercise is asking us is to work backwards. Remember, in the past, we were given the value of x. In the previous exercise, we knew that x equals 4, if I remember correctly. We knew that in the past exercise. But we didn't know the slope, the gradient. We didn't know it, so we need to find it, right? In this exercise, we are working backwards because we don't know the value of x. That is what the exercise is asking us. Find the value of x. But what we do know is the gradient. You see, we're working backwards. So what we're going to do first is find the gradient function. Find the derivative of y. Because remember, the gradient function is a function that contains every single slope for every single value, right? Well, one of those is going to be equal to 5. So if I find the derivative first and I replace the value of the m of the derivative by 5, I will be able to isolate for x. This is what I mean by that. So doing the derivative first, dy over dx, will be absolutely easy. This function is absolutely easy to derivate. The derivative will be 2x to the 1 over 2. Did you see what I did? 1, the coefficient, times the exponent will be 2. The new exponent is 2 minus 1, so just 1. And the denominator, the over 2, I'm just going to leave it there because it doesn't matter. It doesn't affect my derivative. Now, some of you might look at this and might say, but teacher, you can cancel this. And yes, I can. I'm going to do that cancellation in the next step, right? Following this, plus x, so the derivative of x will be just 1. And the derivative of negative 3 will be 0, so I'm not going to put it. It will be plus 0, but I'm not going to put it there. Okay, now the derivative, if I do the cancellation, will be dy over dx. This will be x plus 1, right? I cancel the 2 and the 2, so it will be just x plus 1. Beautiful. So now I have my gradient of my function gradients. All of this function will tell me the gradients for every single function that we have, every single value. And it turns out that one of those values is x. We don't know for which. We don't know if it is at x equals 1, 2, 3, 11, 20 millions. We don't know. But we know the derivative is 5. So this one, in case you don't remember, this one is the m, the slope. Is the same as saying dy over dx. That 5 is the same derivative that we had. So in this case, I am going to replace dy over dx by 5. So my new function will be 5 equals x plus 1. Again, why am I replacing dy over dx? Because the exercise said that the gradient at this point will be 5. So I don't know what is the point, but I know at that point will be 5. So I can replace the dy over dx, the slope, I can replace it by the value I know. And from here, all I have to do is isolate our x. This step is absolutely simple. Just pass the 1 to subtract. We will have that the new value of x will be 4. 5 minus 1 equals 4. So look at the question. Find the value of x, find x, if the gradient is exactly 5. Well, if the gradient is exactly 5, the value of x equals 4. And there we go. We just found it. This is an example of an exercise that has maybe 1 mark, maybe just 1. So they're probably expecting you to do this in about 1 minute because it is absolutely easy. All right. Does anybody else have another question, maybe?
Yes, me.
Tell me. Absolutely, tell me.
The exercise 6H, exercise 15.
6H 15. All right. But how about this? Did you have any questions about this? No, you good?
19.
19. All right.
Better.
So I can erase this, right? You got it. Cool. You don't need any more
Yes.
assistance. You got everything correct, right?
Yes.
Beautiful. Let me erase this and we'll do the point 19. All right, so point 19 wants as the gradient of the tangent. Let me show it for everybody. Like this, Okay, the gradient, I'm doing point 19 for everybody. The gradient of the tangent to the curve y equals, ooh, that looks good. Y equals px squared plus qx plus qx at the point P, wish they would choose a different value for this. At the point P, 2,5. Okay, is 7. Okay, so we have a function, we have a point, and we know the gradient. The gradient is 7, right? From the point 19. All right, and we need to find the value of P and Q. So these are the ones that we want to find. We want to find P, and we want to find Q. All right, let me switch back to just the board. Okay, so again, we have a function, but we don't know the values of P and Q. We don't know which ones are those. But we know that function at exactly the point P, 2,5, at this point, 2,5, the gradient will be 7. That is what we know. So this is a different example of working backwards. In this exercise, in previous exercise, you were given the function, the point, but you were not given the gradient, and you needed to find it. In the past exercise, you were given the function, the gradient, but not the point, and you needed to find it. Well, guess what? In this case, we are not given the function, but we are given the point and the gradient. So this is another example of working backwards. All right, how are we going to do this? Absolutely simple. We know the gradient of the function is 7. This is a piece of information really, really valuable because we know the dy over dx at this point, 2,5, is equal to 7. That is the idea of gradient, right? So if we find the derivative of our function and replace the value of x by 2, the derivative will be 7. But some of you might be thinking, teacher, how are you going to derivate this thing? We don't know. We don't know the values of P and Q. Yes, we don't know. But we know they are numbers. So this could be 1 and 2 or 0 and 7. I don't think this is 0, but this could be any numbers, right? So we can assume they behave as numbers. What I mean by that is this. Look at this. dy over dx. Let me change markers again. Dy over dx, so the derivative of our function is equal to, and if this is a number, and if this behaves as a number, then the derivative of this will be absolutely simple because you derivate in the same way. You multiply the coefficient by the exponent. So p times 2 is 2p. Sorry guys about that. Let me change for a different color. 2p. Better. Like this is better. All right. Let me start this with green. Dy over dx. I'm going to have to go outside and buy some new markers now. All right. So I'm doing the derivative, right? So the derivative of p times x to the second power. Remember, multiply the coefficient by the exponent. So p times 2, that's 2p. And the exponent of the variable will be 2 minus 1. So this is just 1. I'm not even going to put a 1 right there because it is times elevated to the first power, right? So 2px plus the derivative of qx, sorry. Well, if this behaves as a number, the derivative will just be q. Because q times the exponent, so q times 1 will be q, and the new exponent will be 1 minus 1, so 0. So there is an x to the 0. Beautiful. Now we have our gradient function. And why is this important? Because we know if we replace with the values we know, the derivative, and the value of x, what's going on with the camera? There we go. And if we replace with the derivative by 7 and the value of x, which is 2, we're going to have a easy to solve equation. Look at this. 7, which is the derivative, right? 7 equals to 2p times x. The value of x equals 2 plus q. There we go. All right. If we simplify this, it will be 7 equals 2 by 2 is 4p plus q. All right, we have an equation. The problem is here, our equation has two variables. Remember, we are trying to find the value of p and the value of q. But we cannot isolate p or q from here without depending on the other variable to find it. We have two variables. All right, maybe if you guys remember, hopefully you guys do, anytime we have our equation with two variables, that makes us remember about something. That makes us remember about a system of equations. Because if we have one equation with two variables, there has to be a second equation with the same two variables. That is a system of equations which can be solved with elimination, substitution, I don't know, matrices, whatever process you choose, or just by using the calculator, of course, right? So again, we have our first equation. I'm going to call it first. We have our first equation. But we don't have a second one. Well, we need to find it. And the second equation will be found by replacing the values of x and y, but not in the derivative. No, in the function itself. So y, which is the first function, y, is going to be the value of y. So 5, remember, our point is 2, 5. 2 is for x and 5 is for y. So if I replace the values of x and y, I'm going to have a second equation. So x equals p times x, which is 2, 2 to the 2, right? X to the 2, 2 to the 2, right? And then plus q, which is our variable. We want to find that q times x. So again, times 2. Let me do it like this. All right. So this 5 looks like an S, sorry. This 5 will be the result of 2 to the 2, which is 4. So 4p plus 2q. And look at this. We now have a second equation. This is the first one, and this is the second equation, second. Our second equation. We have our first and our second equation. So we have a system of equations that can be simplified using any process that you want. I'm going to do it real quick using what? Let's say elimination. Elimination. All right? Elimination. So how do you do this with elimination? I'm going to subtract equation 1 from equation 2. So 5 equals 4p plus 2q minus the first equation. 7 equals 4p plus q. All right. If I subtract these two equations, this is a regular process of elimination. In case you don't remember or you don't like using elimination, you can use any other process. And you can even just put it in the calculator, right? There's a solver for these. All right. By subtracting, I'm going to subtract each part individually. What I mean by that is 5 minus 7 will give me negative 2, right? Then 4p minus 4p will be 0. I'm just going to write a line. Like this, I cancel the value of p. Now, 2q minus q will just be q. And look at this. Now we have the value of q. Q has to be equal to negative 2. We have our first solution. We have the value of q. Remember, the question says, find the values of p and q with this information. So we just did. We just found the value of q. There we go. I'm going to put it over here. And now that we have the value of q, we can replace q in any equation that we have, in the first one or in the second one. By doing so, we will have the value of p. So replacing in which one would be easier? I feel like the first one will be easier. So replacing in the first. Replacing in the first, right? I'm going to take the first equation, 7 equals 4p plus q, but now q equals negative 2. So I replace the value of q in the first equation, and all I have to do is isolate p. Pass the negative 2 to add will be 9 equals 4p, and then isolate for p to by passing the 4 to divide. So 9 over 4 will be the value of p. And look at this. Now we have the two values. P equals 9 over 4. Q equals negative 2. Great question. Gabby, was that you?
Yes.
All right. Thank you for asking, Gabby. Excellent question. This exercise is absolutely interesting. This one, it combines a lot of things. It combines a lot of the derivatives that we have been talking about and finding the gradient function and knowing how to find tangents and normals. But not only that, it combines a topic that you guys even practice in 9th grade, which is a system of equations. And I choose to do it by elimination, but there are a ton of ways of solving this system of equations. So yeah, excellent question. Thank you, Gabby. I appreciate it. Do you have any questions about this?
How do I do it by substitution in that case?
All right. By substitution, if you want to do it by substitution, what you should do first is choose a variable in one equation. So you could choose p or q in the first one, or maybe p or q in the second one, right? And then isolate that variable and replace it in the second equation. Do you want me to do it?
Okay.
Sure. All right. Let me erase this part here. Elimination. It should give us the same, right? It should. All right. So by substitution. Substitution. All right. By substitution, I am going to isolate q from the first equation. Why q and why the first one? Sorry. Well, because I find q to be the easiest because it doesn't have any coefficients. So I don't have to pass anything to divide. If I were to isolate q from here or p from here, I would eventually have to pass the 2 to divide or the 4 to divide. Same here with this p. The 4 will have to go to divide eventually. And I don't want that. I don't like working with fractions. So I feel like isolating q is a lot easier for that reason. So if I isolate q will be equal to 7 minus 4p, right? This is me isolating q from the first equation. Q is now 7 minus 4p. Remember, the 4p passes the subtract, so 7 minus 4p. Beautiful. Now that we have it, we are going to substitute. We're going to substitute q in the second equation by the value of 7 minus 4q. So substituting in second. All right, let's substitute in the second one. So the second equation is 5 equals 4p plus 2 times q, and q is 7 minus 4p, right? Instead of the q, we wrote the value of q, 7 minus 4p. That is why this is called substitution, because I substitute the value of q by something else. From here, just do algebra and isolate for p. So I'm gonna have 5 equals 4p plus 14 if I do this distributive here, 2 times 7, and then 2 times 4p, so minus 8p, right? By doing algebra real quick, I see that 4p minus 8p, that will be negative 4p. And I can pass the 14 to subtract, right? So I will have 5 minus 14 equal to negative 4p, right? Now, how much is 5 minus 14? Well, this is negative 9, right? And if I isolate for p, pass the negative 4 to divide, this will be negative 9 over negative 4. And this will be the value of p. Now, some of you might be saying, teacher, it gave us negative. Sure, but it gave us negative on both numerator and denominator. So we can cancel those negatives right away. In that case, the value of p will be 9 over 4. And like I said at the beginning, it should give us the same values. And it did for p. Now, from p, how can we find the value of q? Well, easy. Just like in elimination, we're going to replace the value of p in the first one or the second equation, whatever you feel like it is easier. I feel it is a lot easier in the first one as well. So, replacing in the first one, will give me the value of q. All I have to replace is p for 9 over 4. So 7 equals 4 times p, so 4 times 9 over 4 plus q. But look at this. The 4 and the 4 can be canceled because this one is multiplying and this one is dividing, so I can cancel those 4s. And the new equation will be 7 equals 9 plus q. From here, pass the 9 to subtract, will be 7 minus 9. So this is negative 2. And in the other side of my equality will be just q. So from here, I now have the value of q, which was the same than the one we get from elimination. So p, 9 over 4, and q, negative 2. This is how you do it with elimination, Gabby.
Thank you.
Elimination, substitution, sorry. Tell me, yes.
So in these exercises, the 15 to the 20 are like this. So we try to derivate the question without the numbers, and then we do the system of equation.
Yes. All right. Let me see. Exactly like that. Exactly. If you're missing a piece of information, what the exercise is hoping you to do is to work backwards. So exactly this, right? If the reason why we knew from the beginning I should do a system of equations is because I have two variables, p and q. If that happens in the rest of the exercises, if you still have p and q, or I don't know, k and l, m and n, any two variables, then that is a real strong way to notice that you may have to do a system of equations because there are two variables, right? Maybe in an exercise there is only one variable. Maybe there's an exercise where the question is just find p. If you only need to find one, then you don't need to do the system of equations. All right. So it depends on the question. Really, it depends on the question. But yes, most of the time you have to do the system of equations. Now, since you are working in a class of mathematical studies, you can jump these. You can jump it and just find the solutions, P and Q, by using your calculator. That you can do. All right?
Okay. With the solver? With what?
No. Depends.
Yes,
it depends on the type of calculator that you have. Remember, if you have a Texas, there's an option for you to do it with a matrix, right? You write in a matrix, yes. You write the values, the coefficients, 5, 4, and 2, right? And 7, 4, and 1. You write down the coefficients, and by doing row reduce echelon form, you can find the solutions for P and Q, all right? And if you're working in the Casio calculator, there's a solver for you, right? You go to solver, and then it says simultaneous equation, I think. And you can write the two equations, press enter, and it will give you the values for P and Q. All right.
All right, thank you.
Thanks to you, Gabi. Guys, it is exactly 11 o'clock. So thank you all for coming. Get to work on those exercises. Please study a lot. All right. Because next class, we are going to have a quiz. All right. And the quiz will be held the first 15 minutes of the class without you reading anything, without you doing any other exercise. So please practice. And if you have any questions, you can write to my email, and I'll try to answer as soon as I can. All right, I promise you that. See you all, guys. See you. Bye bye. Yeah.
Bye.
Bye.
Bye, teacher. Thank you.